Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem, and this problem is also selected from the book Modern Physics by Kenneth S. Crane. Okay. Since we have introduced books for various courses of physics, all problems have yet been selected from Kenneth S. Crane. Okay, Modern Physics by Kenneth S. Crane. Its statement is find the momentum, kinetic energy and total energy of a proton moving at a speed of 0.756 c. C meaning speed of light. Okay. So as usual, here dear students, we have to find out three things. Okay, momentum number one, number two kinetic energy, and then total energy. Okay, here parts A, B, C, X are not given. Okay, however, these could be arranged in such a manner, but nevertheless, it does not make any difference. Okay. So as usual, first we will come towards helping tools. Okay, because before proper alignment and calibration, toolkit is necessary to be fully compatible. Okay, helping tools. Tool number one, relativistic momentum. P is equal to mu over 1 minus u square over c square. Okay, it can alternatively be written as p equal to gamma mu. Okay, because 1 over 1 minus u square over c square is called Lorentz factor and is denoted by gamma. Okay, this thing we taught in our previous video. Okay, now we move to tool number two. Okay, tool number two deals with relativistic kinetic energy. Okay, relativistic kinetic energy K is equal to mc square over 1 minus v square over c square minus mc square. This alternatively becomes equal to gamma minus 1 within bracket and then multiplied with mc square. Okay, here K is the relativistic kinetic energy, m is the rest mass of particle, c is the speed of light in vacuum, v is the speed of particle, gamma is the Lorentz factor relating rest frame of particle and frame of observer. Okay, now we move to third tool. Okay, third tool deals with total energy. Okay, total energy of a particle E is equal to kinetic energy K plus rest energy mc square. This alternatively becomes equal to mc square over 1 minus v square over c square, or in other words, this alternatively becomes equal to gamma mc square. Okay, where gamma is the Lorentz factor relating rest frame of particle and frame of observer. V is the speed of particle, m is the rest mass of particle, and c is the speed of light in vacuum. Okay, now we move to tool number 4. Okay, some masses in energy units. Okay, electron, hydrogen atom and then proton. Okay, dear students, in this problem we are dealing with proton. Okay, okay, find the momentum, kinetic energy and total energy of a proton. Okay, we are dealing with proton. So in this table, the value given at third row is relevant. Okay, proton 938.3 million electron volt. Okay, so in place of mc square we have to use the value 938.3 million electron volt, or alternatively we can convert it in electron volt, but for the time being we move for, forward. Okay, solution of part A, but here part A is not mentioned, just momentum in place of part A. Okay, so momentum, or in other words the relativistic momentum, because here speed of light is involved. Wherever speed of light becomes comparable with the speed of the particle, then relativistic mechanics becomes our primary concern. Okay, so momentum P is equal to mu over 1 minus u square over c square. Here m is given as 938.27205 million electron volt over c square. Okay, as per table which we have shown in tool number 4. Then u is given in the statement, which is equal to 0.756 c, where c is the speed of light. Moreover, dear students, here 1c will be cancelled out with from c square, and only 1c will remain. However, now we come towards denominator. Okay, 1 minus in place of u 0.756 c square over c square. Here in the under root, c square is in the denominator and c square is in the numerator, and this c square will be cancelled out. Okay, from here 1c will be cancelled out, and only 1c will be left. Okay, so here next step becomes 709.33 million electron volt over c over 1 minus 0.756 square. Okay, because c square have been cancelled, and also 1c from million electron volt over c square has also been cancelled with u, which is given in terms of c 0.756 c. Okay, so this alternatively becomes equal to 709.33 million electron volt over c over under root 1 minus 0.571, from where this 0.571 has become, actually when we take square of 0.756, then it becomes equal to 0.571. Okay, in the next step we have subtracted 0.571 from 1, and it has resulted in 0.429. Okay, in the denominator no change. Even in the next step no change in the denominator, and only change is in the numerator, that is under root of 0.429 is 0.655. Okay, so in the next step million electron volt over c is quite same as in the previous step, no change. We have solved only 709.33 divided by 0.655, and this has resulted in 1082.95 million electron volt over c. Okay, just simplification. There is no need for so much detail, but anyhow I think it is better than omitting this explanation. Okay, so momentum has become equal to 1082.95 or 1082.95 million electron volt over Ce. Now kinetic energy. This expression is also given in the tools. Okay, K is equal kinetic energy. K is equal to mc square into gamma. Gamma is equal to 1 over under root 1 minus u. Dear students, here minor mistake, minor, not major, minor. 1 minus u square, here should be u square, by mistake square has been omitted. Okay, we see here kinetic energy. Okay, mc square over 1 minus v square over c square. So v or u, sometimes we denote by v and sometimes by u. It does not make very much difference. Okay, so here one minor mistake has been pointed out, that here I can still correct this mistake before camera, but I leave such minute things. Okay, it will take enough struggle. I shall have to go to math type, and then I shall have to copy, cut paste from this and paste it in math type software, and there I shall insert 2 at u, and then I shall again cut from math type and paste it here. So in place of so lengthy process, it is quite sufficient that I am pointing out here that there is a minor mistake, that u is not single but it is a square. Okay, 1 minus u square over c square minus mc square. Okay, dear students, here in place of mc square we have used value 938.27 million electron volt. Okay, moreover, in the denominator 1 minus u square over c square we have already calculated this figure 0.655. That is why we have directly put this value in place of under root 1 minus u square over c square. Okay, from where this value has become 0.655, we move back. Okay, yes, this is 0.655 in the previous page. Okay, that is 1 minus u square over c square. From here it runs, it goes to this step, after this it goes to this step, then it goes to this step, then it goes to this step, then it becomes this. Okay, so in part B, that is kinetic energy, we have directly used the value 0.655 minus, in place of mc square, once again this value. Okay, after simplification it becomes 1432.47 million electron volt minus 938.27 million electron volt. So both units are same, so it can be easily subtracted, and after subtraction we will get the value 494.203 million electron volt. Okay, this is kinetic energy. Now we come towards total energy. Dear students, this total energy is also given in tool. Okay, this expression is shown in detail in toolkit. Okay, total energy is equal to total energy E is equal to K plus mc square. This alternatively becomes equal to mc square over 1 minus u square over c square, and here in place of mc square we have taken the value as per table. Okay, 938.27 million electron volt, and here once again we have put 0.655, which we have calculated in not previous but previous than previous step. Okay, in the previous step we have also used this value directly, but in one step further back we had calculated this value in detail. Okay, so this its unit is the same, million electron volt. We have just simplified this expression, 938.27 divided by 0.655, and here total energy becomes equal to 1432.47 million electron volt. And this is the end of our problem, our video. Till next video, Allah Hafiz.